Okay, this mini lecture is about solving and graphing inequalities and writing the answer in interval notation. So we're going to start with this first example here. This is called set notation. You see that this has the little braces, and that represents a set. And this is read the set of all x's such that x is greater than or equal to 3. And so this line means such that. And this is basically representing all the numbers that are greater than 3 or equal to 3. So 3 will actually be included into this set because of the equal to. Now, if we want to graph this solution as the directions say, then first we're going to fill out this number line. Many of the problems you don't necessarily have to start with 0, but let's just do it for this one so that we can refamiliarize ourselves with the number line. Okay? And this is going to keep going, and this direction will be -1 and -2. Okay, so at 3, we're looking for numbers that are greater than 3. So what numbers are greater than 3? Well, 4 is greater than 3. 5, which would be here, would be greater than 3. What about 3.5? That's greater than 3. 3.1, 3.001, so right up to 3 is greater than 3. And we also have this equal to mark, so this is saying or 3 itself. So all of these numbers going to the right are part of our solution set. Now, you may remember from high school or from another institution that in the past you may have put a open circle there on the graph to represent either less than or greater than, and you may have put a closed circle to represent less than or equal to, greater than or equal to. Here in college, we are going to do things a little bit differently. So instead of an open circle for less than or greater than, we're going to do parentheses. And instead of a closed circle, we're going to do brackets. And we're going to actually do that on the graph itself. So on this graph, we have an equal to. So right at 3, we're going to draw a line and make that a bracket going through 3, facing the shaded area. So this is sufficient to graph this set. Now, our interval notation is describing the shaded area from left to right. So if we start on the left side of the graph, what we're looking for is the first place that's shaded, and that happens to be 3. So 3 is where we start, and how far do we go? Well, this keeps going on and on and on forever. So in mathematical terms, that means infinity. So our starting place would be 3, and then we put a comma and we write where it ends. Well, because this doesn't end, we write infinity. And you should make a note that infinity or negative infinity is also going to get parentheses. So the only thing that's getting a bracket is when we have that line underneath. So this is going to be bracket 3, comma, infinity, close parentheses. All right, so notice that this was already set up as x greater than or equal to some number or x inequality some number. You didn't have to do any work for that. On example 2, it is not in this format. So we need to actually solve for x here. And you solve it very similarly to a linear equation. So for a linear equation, you're just solving for x by moving the x's together and the numbers on the other side. So we're going to do the same thing here. So we're going to subtract 6x from both sides. This is -2x minus 1 is greater than 9. And we're going to add 1. So I get -2x is greater than 10. And let me come over here and write that again because we're running out of room here. Okay, and then here's where things are different with an inequality. If I have a number in front of x and I want to divide both sides by this number, just like we do with the linear, if this number is negative, and in this case it is, then I would change the inequality sign. So you're going to flip this around. So instead of greater than, I'm going to have less than. Now this is not going to affect the answer itself. So this is still just going to be whatever you get. So 10 divided by -2 gives me -5. Okay. Now I'm not going to start at 0 here because that would make it really inefficient. So whatever we get here, this is what we're going to put in the middle of our graph. And I usually just go 1 down and 1 up, and keep in mind this is negative. So if I go 1 down negatives, that's going to be actually -6. And if I go 1 up, that's -4. Okay? All right, so we flip that over when we divide by a negative. I do want to say real quick that this number here that's on the right hand side, it does not matter the sign. If this was negative, it wouldn't matter. That does not determine whether you're going to flip this inequality over. It's only the sign of the number in front of the x. All right? So let's graph this solution. We have x less than -5. If you solve for x and you put the x on the left-hand side, you will always be told, this arrow will tell you which way to graph. So notice that this is pointing to the left, like it's shading to the left. Okay, and this arrow matches this arrow, so it's telling you which way to shade. If we logic this out, numbers that are less than -5 would be numbers that go to the left side of this. Okay, so we're going to shade first. Start at -5 and keep shading. Okay, and then let's go to our chart. This is just a less than. There's no equal to with it. So our less than had a parentheses. So right here at 5, we're going to do a parentheses through -5. Now always shade first so I know which way to, face that parentheses. All right. Interval notation. I talked about it being from left to right, and it is that way over here also, but I want to show you a little bit different way for this one. If we put the comma down first, I want you to think about which direction is this arrow pointing. This direction is left. Well, which direction do we shade? We shaded to the left. That direction is always going to be where the infinity sign is. So if this points left, you shade to the left and infinity is on the left. So here we have infinity. And this makes sense because how far left does this go? Well, it keeps on going. The key on this one is that we are going in the negative direction. So our infinity will also be negative. And if we remember, infinity also gets a parentheses. Okay? And then on the other side is where it stops. So it is always going to be this number. So this number goes on the right-hand side, and it had a parentheses on the graph. So this is just different ways to represent the same thing. X is less than -5. This goes to the left side, and negative infinity to -5. All of those mean the same thing and represent the same thing. Okay, so important, what do you need to remember when working with inequalities? When you divide by a negative, flip the inequality sign. Okay. My apologies for that technical glitch. Okay, moving on. We have absolute value equations. So notice that these have the equal sign in here and not less than or greater than sign. We're going to get to those, obviously, you see right here. So how do we tackle these absolute value equations? I want you to think about an absolute value and what it actually means. So if I had an absolute value of, let's say, 2, absolute value is the distance from 0 on a number line. So if I have a number line, and this is 0, and this is 1, and this is 2, how many units am I from 0? Well, I'm 1, 2 units. So this is why I get 2 for that answer. What is the absolute value of -2? Okay, so let's think about this. Again, this is the distance from 0 on a number line. So if this is -1, and if this is -2, then I'm also 1, 2 units from 0. So this answer is also 2. And so absolute value never gives you a negative result. The answer is always positive because distance is always positive. And the thing to remember with this is how many numbers, how many different variations can I have and get the same answer? And because the number line goes in the positive direction and the negative direction, you have two different things that you could plug in and put in the middle of this absolute value to get the same result. We have to take that into consideration when we're looking at absolute value equations and inequalities. So notice I can do a positive number inside and get 2, and I can do a negative number inside and also get that same 2. So that's what we're going to do here. We cannot work this with these absolute value bars still on it. So we're going to separate this into two different equations. And we're, by doing this, taking the absolute value bars off. So on this side, and this is really important that you pay attention to how I'm doing this, okay? On this side, you're going to write exactly what you see, except for you're going to take the absolute value bars off. So here I'm just going to have x plus 3 equals 2. Simple enough. On this side, I'm going to have x plus 3 equals -2. So I'm taking into consideration that I can get a positive or a negative inside, and it would give me that positive answer. I'd get the same thing, okay? So again, same thing on this side, change the sign on this side. So I'm changing it from on the right-hand side number. All right, now we're going to solve both of these. So -3 on both sides. Here I get -1. -3 on both sides. Here I get -5. Now the answer to this is not an interval. You just have two answers. It's just a solution, two solutions, -5 and -1. There's no parentheses because this is not an ordered pair. So you just list, similar to what you had for like quadratic equations or listing the zeros of a polynomial, okay? All right, that was the equations. What happens if we have inequalities? Well, the thought process is the same. We just have to kind of take this inequality sign into consideration. So we will have two different versions. On the right-hand side, this is going to be 2x plus 1 greater than or equal to 7. So notice it's exactly the same thing as the problem, just without the absolute value bars. On this hand side, we're going to have 2x plus 1, flip the inequality, flip. So instead of greater than, now I've got less than or equal to. And then we're going to change the sign of this. So we're doing a flip change here, -7. Setup for this is so important. Make sure you're putting the correct things on the correct side. Otherwise, you may still get the right answer, but you may not be able to interpret that very well because things are going to be kind of out of order. And you'll see what I mean in a minute. So let's solve both of these. So -1, I've got 2x greater than or equal to 6, divide by 2, and x is greater than or equal to 3. Here, -1, I've got 2x is less than or equal to -8, divided by 2, and x is less than or equal to -4. So what I meant was, if you put these in the reverse order, now you've got a negative on this side and a positive on this side, and even your number line is in the wrong order. So again, it's really important that you put what you see without the brackets on the right, and then flip change on the left. Okay? Now, let's see what this means for the integral notation in the graph. So here I've got -4. Here I've got 3. Let's take it in pieces. So x is less than or equal to -4. So at -4, it's going to the left. This has an equal to, so at -4, I'm going to have a bracket. Again, that's the only time you have a bracket is if you have that little line underneath. Let me do this. There we go. All right, let's look on this side. 3, we've got x is greater than or equal to 3. So from 3, we're going greater than. That means it's pointing to the right, so we're going to shade to the right. And again, it has the little line underneath, so this is going to be a bracket facing the shaded area. Now, interval notation for this is quite interesting because we have 2 different intervals. So let's take it in pieces and then I'll talk about what we have to put in the middle here. So how would I write this interval? Well, if I'm going to the left, then this is going to be negative infinity up to -4. And one more time, just on that trick, if the arrow points left, you shade to the left and infinity is on the left and it's negative. Okay, let's look at this one. I've got an arrow that points right. I shade to the right and infinity is on the right. So on the left side here is the number. And I just realized I messed up right there because this should have been a bracket. So that should have been a bracket. Now, when you've got 2 different sets, 2 different intervals, but one answer, I need to be able to join these together in the same answer, in the same interval notation. And we use what's called the union symbol. Think of this kind of like, you know, 2 people getting married. It's a union of 2 people, right? So this is kind of the joining of 2 intervals together so that you can write it as one answer. Okay, so anytime that you skip over something, you skip over a part of the graph, whether that be a big segment or just one number, you're still going to put the union in here. Okay? All right, I have included a nifty little chart on the problem setup. So if it's set up like this, this is how, or if the problem is like this is how you would set it up. This is what your number line would look like, and this would be your solution set. Okay, so you can definitely use this as a reference as working your problems and helping you in your normal 101 class.